Welcome to the DIY Honda Garage channel. The DTC codes P0351, P0352, P0353, and P0354 relate to ignition coil circuit malfunctions in the Honda HR-V models from 2016 to 2022. These codes indicate that there is an issue with the ignition coils responsible for igniting the air-fuel mixture in the engine cylinders. Each code corresponds to a specific cylinder: P0351 to number 1, P0352 to number 2, P0353 to number 3, and P0354 to number 4. The ignition coils are typically located on the engine cylinder head, attached directly to the spark plugs, providing the necessary spark to start the combustion process. The malfunction may arise from various issues like shorts, opens, or other electrical problems. Identifying and rectifying these issues promptly is essential for vehicle performance and to avoid further damage. DTC P0351, P0352, P0353, and P0354 indicate a specific fault in the ignition coil circuits for each respective cylinder in the Honda HR-V. An ignition coil's primary function is to convert the vehicle's battery voltage into a high-voltage spark that ignites the fuel in the engine's combustion chamber. Each cylinder has its ignition coil mounted directly on the cylinder head, ensuring that the spark plug receives the required spark at the right moment to maintain engine performance. These error codes signify that there are malfunctions in these circuits that can hinder the ignition process, leading to poor engine performance and rough running. Addressing these codes begins with a thorough diagnostic assessment to determine whether the issue is isolated to one cylinder or affects multiple coils. The causes for these DTCs can stem from various electrical issues. Firstly, a faulty ignition coil can directly cause ignition circuit malfunctions. This could be due to wear and tear, overheating, or manufacturing defects. Additionally, bad wiring connections like loose or corroded connectors can lead to poor electrical transmission, similarly affecting performance. Shorted wires, which occur when insulation is damaged and wires touch, can create a circuit malfunction. Open circuits, where a wire is broken and fails to complete a circuit, will essentially disconnect the ignition coil from its power source. Lastly, a defective ignition relay may not supply the necessary current to the ignition coils, leading to these error codes being generated. Symptoms of an ignition coil malfunction associated with these DTCs include engine misfires, which occur when the fuel in one or more cylinders does not ignite properly. These misfires can lead to a noticeable decline in fuel efficiency as the engine compensates and struggles to maintain performance. Additionally, drivers may experience rough idling, where the engine vibrates or shakes irregularly when at rest. An illuminated check engine light will typically alert the driver to the presence of trouble codes like P0351, P0352, P0353, and P0354. Difficulty starting the engine may also occur, owing to insufficient spark delivery from the malfunctioning ignition coils. Addressing these symptoms early can prevent more significant engine problems in the long run. In the first troubleshooting step, you will turn the ignition switch to the on mode without starting the engine. This allows the vehicle systems to initialize. Next, use the Honda Diagnostic System, HDS, to clear any existing DTCs from the vehicle's memory. Clearing the codes will provide a clean slate to work from and help in accurately detecting current issues. After the codes are cleared, start the engine and monitor for any new or reoccurring DTCs. It's crucial to check whether DTC P0351, P0352, P0353, or P0354 reappears. indicating that the failure has duplicated. If so, proceed to the next troubleshooting step. If not, this may indicate an intermittent failure, suggesting checking for poor connections or loose terminals. For the second troubleshooting step, turn the vehicle's ignition to the off mode. This ensures safety while you work on the ignition system. Focus on the ignition coil that corresponds to the identified DTC, example number 1 for P0351, and exchange it with an operational ignition coil from another cylinder. It is essential to ensure that the swapped coil is functioning correctly to rule it out as the source of the problem. After the exchange, restart the engine and again check for any new or pending DTCs using the HDS. If the same DTC appears at the exchanged position, it confirms the fault is with the ignition coil, necessitating its replacement. If the DTC does not reappear, it may indicate further issues in the circuit. In the third troubleshooting step, switch the vehicle ignition to off mode to safely conduct electrical checks. Next, you will check the fuse number B8, which is a 15-amp fuse located in the underhood fuse relay box. This fuse plays a crucial role in providing power to the ignition coils. If the B8 fuse is blown, it indicates a possible short in the IG1 ignition coil or IG1 coil wiring. In this case, you will need to identify and repair the short circuit to restore functionality. After addressing any wiring issues, replace the blown B8 fuse to ensure the electrical circuit is complete. If the fuse is intact, you can proceed to the next step, as this indicates that the circuit is not the source of the problem. Moving to the fourth troubleshooting step, remove the ignition coil relay from the underhood fuse relay box. The relay controls the flow of electricity to the ignition coils and is vital for their operation. Once you've removed it, test the relay to ensure it functions correctly. Should the relay fail to provide proper operation, it will need to be replaced. If the relay works, the problem may lie within the wires or other components of the ignition coil circuit. Proper relay function is essential, and it's advisable to verify that all connections are secure before moving on to further troubleshooting. Relays are subject to operational failures, often requiring replacement if they do not meet specifications. In the fifth step, reinsert the ignition coil relay back into the underhood fuse/relay box to restore normal operations. Next, disconnect the 3P connector from the affected ignition coil. This action is vital to isolate voltage measurements effectively. Set the vehicle to on mode to enable voltage check. Measure the voltage between the specified test points. The first point is the ignition coil 3P connector, number 1, and the second point is a body ground. This measurement helps you verify whether voltage flows correctly to the ignition coil from the ignition relay circuit. If you find sufficient battery voltage at the connector, this indicates the IG1 wiring is intact. If there's no voltage, it suggests an open circuit or short within the wire between the ignition coil and the ignition coil relay, warranting necessary repairs. For step 6, turn the ignition switch back to off mode to ensure safety. Following this, you need to check for continuity between the specified test points to ensure all wiring is intact. Disconnect the 3P connector for the ignition coil to isolate the circuit. Test the continuity between test point 1, which is ignition coil 3P connector number 2, and test point 2, which serves as body ground. This continuity test helps in verifying the integrity of the PG coil. Wire, which is vital for the ignition coil's functioning. If continuity is confirmed, the PG wire is functioning correctly. However, should the test reveal no continuity, repairs must be made in the PG wire between the ignition coil and its respective ground point. Step 7. involves jumping the SCS, System Control Software, line with the HDS to facilitate further electrical checks. Once this is done, disconnect the PCM, Powertrain Control Module, Connector C, which integrates the powertrain systems in vehicles. This assessment focuses on checking for continuity between body ground and the appropriate PCM connector terminal of the problematic ignition coil. This is particularly designed to verify proper operational pathways, test continuity between the ground and designated pins corresponding to the cylinders with the DTCs. If continuity exists, it indicates that the wiring is functional, and the issue may not be on the wiring side. However, if tested and found lacking, this points toward shorting or wiring failure in the circuit. In the 8th troubleshooting step, conduct a continuity check between the specified terminals of the ignition coil 3P connector and the relevant PCM connector. This verification is critical in determining the integrity of the wiring and electrical communications between components. Make sure that you have the wire of the problem cylinder disconnected. If continuity is confirmed, the wiring is intact, and the problem may lie with the PCM software, which may require an update or replacement with a known good unit. Conversely, discovered issues such as a lack of continuity indicate an open segment within the IGN wire. Immediate repairs are crucial to restore proper ignition coil function and eliminate the DTCs. Upon completing the repair processes for DTCs P0351, P0352, P0353, and P0354, it is essential to conduct a final verification step. Begin by rechecking all electrical connections involved in the ignition circuit to ensure everything is secure and properly set. Utilizing the HDS, clear any present DTCs from the vehicle system. Following this, restart the engine to allow the vehicle systems to cycle. Monitor the vehicle closely to ensure no DTCs return. Confirming that DTCs P0351 through P0354 do not reappear validates that the repairs have successfully resolved the underlying issues and that the ignition system is functioning as intended. Preventive maintenance plays a vital role in enhancing the longevity and reliability of the ignition coil system. Regular inspections of the ignition coils for signs of wear, such as cracks or corrosion, can help identify issues before they escalate. Additionally, it's essential to routinely check wiring for any signs of damage, which can lead to shorts or open circuits impacting performance. Ensuring that all connections, especially those connected to critical components, are secure can prevent unexpected failures. Moreover, clean and well-maintained ground points contribute significantly to the efficiency of electrical circuits. By engaging in these preventive measures, you can minimize the chances of encountering issues related to DTCs P0351, P0352, P0353, and P0354 in your Honda HR-V. In conclusion, understanding the causes and symptoms associated with DTCs P0351, P0352, P0353, and P0354 is crucial for effective diagnosis and repair. By following a systematic approach to troubleshooting, including verifying connections, checking relays, and assessing wiring, you can accurately determine the source of ignition coil circuit malfunctions. Successfully verifying repairs will ensure that the vehicle operates efficiently and prevents further engine performance issues. Finally, engaging in preventive care by routinely inspecting ignition components and ensuring all electrical connections are secure can save time and costs in the long run. Continued vigilance will help maintain the Honda HR-V in top operating condition. Please like and subscribe to the channel. See you next time.